Okay, so back to number 3 here. On number 3 then, again, as I was saying, we want to go ahead and use our midpoint formula now, because that's going to be the quickest way. It's taking the x's, add them together, divide by 2, taking the y coordinates, add them together, divide by 2. It's always the average of the x's, average of the y's. Now, which one do you call x1 and y1? I don't care. X1, y1, x2, y2, it does not matter. You can call these 2's over here and 1's there. We could reverse it. I don't care. Just be consistent. You have the first point, and then you have the second point. So I just usually go, hey, in order, x1, y1, and then x2, y2. But again, it's the, right here, average of the x's. So what do we have? Average of the x's is 2 plus -5, always divided by 2. This is going to give you your first x. And then for the y, we're going to do y1 plus y2. So 3 plus 11 divided by 2. So 2 plus -5 is -3 divided by 2. And 3 plus 11 is 14 divided by 2. Divide what you can, and -3/2, again, I'll take either one, the fraction or the decimal. I just will go with the fraction. And therefore, the midpoint of this segment, AB, is at -3/2, comma 7. Add up the x's, divide by 2, add up the y's, divide by 2. On CD, like I said, I don't care which you call these. I can go ahead and call this x2, y2 to start off with. Just be consistent, okay? Don't mix together and accidentally say like, hey, this is x1, x1 and y2, and then this one is, no, you gotta keep the 2's and 1's together. So in this instance, finding the midpoint, average of the x's, 6 plus 10 divided by 2, and -11 plus 16 divided by 2. 6 plus 10 is 16. 16 divided by 2 will eventually give me 8. And -11 plus 16 is 5. Again, divide where you can. 8, 5/2, I just leave it as a fraction. And then my midpoint is located at 8, comma 5/2. All right, letter C. M is the midpoint of AB. A is located at -2, -4, and B is located at 4, -12. What is the length of MA? So here, I want to keep in mind that I am trying to find actually a length, not a location, but a length. This one can be done 2 different ways. Now, I have a lot of students that will go ahead and just jump right into finding the midpoint, and then we go through and use our distance formula back from lesson 3. Well, there's another way to tackle this. This is not to scale by any means, but A is down here and say, whoops, yeah, and B is way down here at 4, -12. M is somewhere in the middle. I can go ahead and just use my distance formula for segment AB, and whatever I find for that length, let's say the length turned out to be, say, 10. Well, what's half of 10? Therefore, I'm going to have the length of then MA. So that way, I don't even have to worry about using the midpoint formula in this problem. So distance of A to B, I'm going to use my distance formula. x2 minus x1 squared, and y2 minus y1 squared. Okay, that's our distance formula back from lesson 3. So I don't care which one you call x1, y1, x2, y2. Again, it doesn't matter, okay? But now I'm going to go through and plug them in. Change in the x's squared, plus the change in the y's squared. So you better watch out for those negatives. Okay, 4 plus 2 is 6. 6 squared is 36. -12 plus 4 is -8. And -8 squared is always a positive 64. On this line for the distance formula, you should always be getting a positive. 100, and the square root of 100 is 10. Now again, that 10 is not my answer here, okay, that I'm going to put in that grid response. That 10 is the distance from A to B. And the question specifically says, what's the length of MA? So MA is obviously right here, half of 10 then, because the midpoint cuts it in half. Gives me length of MA to be a length of 5. This is a grid response found on the SAT. And if you were taking the PSAT as a 9th grader and 10th grader, you encounter this grid response again. So this is just us trying to get you practice into getting used to how to fill out the grid response. You could fill it out like that. You could also just fill it out in the middle. You could fill it out on the very far edge. We call that justified right, whatever. You don't need to fill in all the leading zeros. Just fill in the 5, but make sure you bubble. Technically, this 5 doesn't have to be up there. These boxes are for you just to have a visual, but make sure you then bubble that in. Okay, the other way we could have tackled this problem was to find the midpoint and then to find the distance from M to A. Now, finding the midpoint, we use our midpoint formula, which in this case would be -2 plus 4, and -4 plus a -12. So when we clean this up to find that midpoint, -2 plus 4 is 2. 2 divided by 2 is 1. -4 plus -12 is -16. -16 divided by 2 is -8. Great. I now have the midpoint, but I'm still going to have to use my distance formula again and find the distance for segment MA. So this option doesn't necessarily save you any time. It's just a second way to show it, but it actually increases your time because you are finding the midpoint. So we found the midpoint to be at 1, -8, and then A is already located at -2, -4. So change in the x's. Now, I don't care if you do -2, then -1, or 1 minus -2. It does not matter, but be consistent then for the y's. If I start off with 1, I better start off with -8. Okay. 1 minus -2 is 3. 3 squared is 9. -8 minus -4 is -4. So -4 squared is 16. 9 plus 16 is 25, and the square root of 25 is 5, just like what we found on the previous way. So more than one way to do math. As long as your work shows mathematically it's sound, I'm good to go.